Hello everyone, this is Jency Monica and this project is based on DSP based digital hearing aid. So first of all, coming to the introduction of this project. So hearing aids are basically devices that are designed to improve the hearing by making sound audible to a person with hearing loss. Hearing aids are a field of medical devices that are powered by digital signal processing techniques. Development of hearing aid modules is realized usually in the first stages using prototyping boards equipped with special embedded DSP. And there are many hearing aid models, that is in the canal, completely in the canal, in the ear and behind the ear. Hearing aids were basically an analog item till the 1990s until the digital technology replaced completely the analog processing. Hearing aid development based on DSP is actually a difficult task, but as an electronic device, the structure of hearing aid looks simple, and the structure is basically an amplifier capturing the ambient sounds by means of a microphone and then amplifying and processing the signal and finally delivering the amplified signal to the earphone. So this is all about the introduction of this project. Now coming to the motivation of this project, that is, we have developed in this project in this research, a simple model of hearing aid that is useful in the study of signal processing steps and algorithms that are implied in the class of biomedical devices. The basic model that is developed is in the MATLAB is translated in the C program-based application using the rapid prototyping techniques with the embedded target module from MATLAB. The code can be improved manually to optimize the application, and new methods of the processing are investigated for a possible inclusion in the model. A new possibility, that is the improvement by integration in a local network, is also considered. This could enhance the patient assistance if used in an hospital environment, and a real improvement to the emphasis. The educational aspect is to try and implement on the modern devices like tablets and smartphones. Now coming to the literature survey of this project. In this, the first paper that we have referred to is the 6th IEEE International Conference on E-Health and Bioengineering. The detection methodology used here is, the development of hearing aids is done today in an environment with advanced features of digital processing like MATLAB, where it is possible to verify the development chain from concept to full signal processing. Next, advantages: the large variety of signal processing tasks, improving the functionality and eliminating the unwanted effects. And the disadvantages are, a major problem is any audio digital signal device is the processing delay and the transition time. Next paper is Atul and Rabiner, a pattern recognition approach to voice-unvoiced silence classification with applications to speech recognition. The IEEE transactions and acoustics, speech and signal processing. The detection methodology used here is, setup and developments are done using prototype boards with the necessary resources, and the advantages is a new possibility, the improvement by integration in local network is being considered in this. And the disadvantages are, the resulting voice has a metallic sound, but it is clearly more intelligible compared with the original sound corrupted by noise. Thank you.
Okay, we continue with the literature survey. The next paper we have referred is Deep Learning Reinvents the Hearing Aid. This paper is, the detection methodology used in this paper is machine learning based deep neural network. Advantages of this paper is, the auditory system, it will separate the speech from the noise. But the disadvantages is sometimes still the noise is quite similar with the noise of the program. Next paper is optimized realization of the wide dynamic range compression based on DSP 5535 hearing aid platform. This paper is published on 2016. The detection methodology is fast Fourier transform algorithm, feedback cancellation algorithm, variable multiblind loudness and subband compression algorithm are used. Advantages of this paper is, these methods are use some low power consumption, but the disadvantages is sometimes these methods will not be suitable when the frequency of the sound is more. Okay, now we will see the methodology. Almost all digital hearing aid contains the same hardware unit. as it contains microphones, some kind of impedance matching networks, anti-aliasing filters, preamplifier, analog to digital converter, some specific processor to support the signal processing algorithms after the digital to analog converter, post amplifier and the speaker. For the purpose of this project, implementation is done on the Xilinx Spartan 3 FPGA board. FPGA board contain onboard codec which performs the ADC and the DAC operations, analog to digital conversion and digital to analog conversion. Now FPGA chip contains some memory element to store the samples from the ADC. These samples in the memory are stored in the first in first out manner. 16 samples of the first in first out queues are collected and proceed through the FFT block, where the time domain signals are converted back into the frequency domain. According to the user convenient, desired bands of frequencies are amplified. The gain of the amplifier signal is to be changed by the doctor using USB or a serial UART interface to the PC. After converting the signal from time domain to the frequency domain, complex signal processing algorithms are used like echo and feedback cancellations, noise reduction filtering, adaptive filtering cancellation. These techniques are used to improve the hearing. Finally, each frequency bands are converted back into the time domain using inverse fast Fourier transform algorithm and given back to the memory. These memory are the input to the digital to analog converter, and analog output of the DAC is delivered to the speaker. This is the flow chart of this methodology.
Hello everyone, I am Tayamma. Now I am explaining about the block diagram of digital hearing instrument. The hearing instrument we can design by digital and analog also. But compared to analog, the digital hearing system is more accurate. That's the reason we are designed hearing system by using digital. First, microphone. The microphone is a sensor. It will convert the physical signal into a electrical form. Whatever the signal that's coming from the environment, but that is input signal like sound, that should be in a physical form, it will convert it into electrical signal by using a microphone. Then that electrical signal amplitude is very less. We have to increase that amplified by using a free amplifier. After amplified electronic signal, that will convert it into the digital signal by using of analog to digital converter. We are converting into digital forms like zeros and ones form. That digital signal we are filtering by using digital signal processor. Means the processor nothing but filtering that digital signal. Means you are reducing that noise in the signal. After filtered digital signal is going to the D to A converter. Means it will convert it into an analog form. That analog form again the amplitude is very less. Then we are again increasing that amplitude by using a final amplifier. Then receiver will receive that sound. Means this the block diagram is nothing but when you are talking to your phone, someone is talking in other side, we have to receive that sound. These things is happen in fraction of second. We can't imagine also. This is the example of instrumentation of the block diagram of the digital hearing instrument. Now let us talk about the application of the digital hearing system. It is used in audio logic rationalize and adapted to cell phones. We already know that, right? Cell phone, when you are talking to a phone, we have to, when someone is talking in other side, we have to receive that sound, right? By using this digital hearing system, we can use that method also. And noise reduction technique used in audio devices. Means here noise reduction technique used because we are used this system designed by using DSP technique use like FFT technique use fast Fourier transform and inverse fast Fourier transform. It will reduce that noise because we are filtering that signal. That is the reason it is also applicable, and in image processing also it is applicable. Some pathologies including sensorineural hearing loss, conductive hearing loss and single-sided deafness. Single-sided deafness is nothing but one ear is capable of hearing, another ear is not capable of hearing. That time also we have to use this hearing system. In conductive hearing loss, the hearing loss is occurred due to the some problem in conducting the sound waves. in the eardrum and middle layer of the ear, that is ossicle. That hearing loss also you can use this digital hearing system. And sensory neural hearing loss. The hearing loss occurred due to some sensory organs. That hearing loss also you can use this digital hearing system. This is more accurate compared to analog, and this is the best method to use that hearing when you are occurring some hearing losses. This is the best way to use that digital hearing instrument. Then now, what is the results of this project is nothing but we are designed this project, implemented that digital hearing instrument by hardware. We have to design this digital hearing system by using software like J-Link softwares. And this project is nothing but it is the prototype of the digital hearing system. Thank you.
Hello everyone, I am Nikita. So guys, you all already get what we are doing in our project and what we are implementing in our project. So let us continue our project. The main purpose of this project is to develop a digital signal processing platform for the digital hearing aid device. So in the first part, hearing profile of a hearing impaired patient is discussed, which provide an idea about how digital hearing aid can be customized to meet the requirement of the customers. So in the second part, some algorithms for conversion of time domain to frequency domain like wavelet transform and FFT techniques are discussed. In the next part, some complex speech process algorithms are discussed like dynamic range compression, feedback cancellation and adaptive filter approach are discussed. So these algorithms provide an better hearing aid improvement with an high value of the signal to noise ratio. And also we discussed about how the software and hardware are implemented. And also in the real-time signal processing, the latency is the main issue to take care about. And also another problem is like limited amount of memory area and the processing power. So the overlap and overlap save algorithms can be used to overcome these problems in the future design. And also in the case of the feedback path model in the adaptive filter feedback cancellation, and the correlation between near and end signal and loudspeaker signal is also another problem. And to overcome this, decorrelating and preamplifier and AFC algorithms are used to overcome this problem. So these are all the papers we referred for our projects. So this is the link to the individual subject in our project. So subject name are like digital signal processing and application, VLSI technology and BMI. So in the digital signal processing, we are using the signal processing techniques like FFT and IFFT. And so in our project, we are implementing and we are giving a simulation using the MATLAB, using the FFT and IFFT technique. And in the VLSI technology, we are using the FPGA. FPGA is used to implement the hardware. And the human ear is we are using for the BMI. Thank you.